Hello, everyone. Welcome to 3D Natives and Formlabs' webinar, Low Rapid Injection Molding with 3D Printed Molds. My name is Madeline Pryor, and I will be the moderator today. I am here today with Juliette Combe, an applications engineer from Formlabs, who is an expert on this topic. Good afternoon, Juliette.
Good afternoon. Hi, everyone.
I will introduce myself and Juliette a little more in a little bit, but before we get started, and while people are still trickling in, I did just want to take the opportunity to send a first question to all of you to get some information. So Juliette, if you could move to the next slide. And I will just, launch the first question. And there it should be on all your screens. So if you could just take a few moments to answer the question, I'll give you a little bit of time. And actually, what is interesting about this webinar today is instead of quite a few questions in the beginning, we're going to be asking a few questions throughout the presentation, a little more dynamic for all of you, wherever you may be. And also for your information, the webinar today is actually being recorded and the replay will be available on our 3D Natives YouTube channel. If you would like to be notified when it is online, you can subscribe. We have a lot of other exciting 3D printing content. So I see that more than 80% of you have voted, so I think I will just end the poll. There we are. So how familiar are you with injection molding? Well, it seems that we have mostly novices here today. You're in the right place. And still proficient and expert, don't worry, we have something for every level. And I hope it, oh, I didn't share the results, sorry. Here you are, here are the results. And you can see that it's mostly people who would consider themselves novice. We have some proficient and expert. I am definitely looking forward to the questions later. And I will stop sharing that. Great. So could we just move on to the next slide, please? So I'm just going to present the webinar itself right now. On this slide, you can see the agenda for the next hour or so. We're starting with the introduction, which is right now, before moving on to some more information on injection molding in general and how 3D printing can be incorporated, especially for short runs. Next, we will move into the actual workflow management for using 3D printed molds for injection molding before looking at some customer studies. There are a few there, it includes Multiplus and Formlabs Applications, among others. The final 15 minutes of the webinar will be a Q&A session where you can ask questions directly to Juliette. Throughout the webinar, I do just want to encourage you to ask any questions you do have already in the Q&A box, which you might see at the bottom of the screen. We'll see it, and it's just good to have, you can ask, of course, in the chat, but it's less likely we'll see it, so I do encourage you to look in the Q&A box first. And now to the panelists. As I previously stated, my name is Madeline Pryor. I am the English content specialist for 3D Natives, the largest international online media platform on 3D printing, which is available in 4 languages. English, as you might have guessed, but also French, German, and Spanish. I will be, as I said, the moderator of this panel and the Q&A especially. And once again, a reminder, please do ask any questions you have at any point in the Q&A section at the end of the discussion. And now moving on to Juliette. Juliette Combe is an application engineer at Formlabs who is conducting research on 3D printing workflows for engineering and manufacturing. Her scope of work includes collaborations with customers, in-house testing, and knowledge transfer through the creation of technical content and training. Previously, she worked in the Open Innovation Group at GE Power, where she managed projects for the Scientific Collaborations team. She has a master's degree in mechanical engineering from ETHS Zurich and carried out research on nano 3D printing at UC Berkeley. We are very excited to welcome her here today. And as I mentioned, Juliette is coming to us from Formlabs, which I assume most of you have at least heard of, but just in case, to introduce the company a little more, it is headquartered in Somerville, Massachusetts, with offices in Germany, Japan, China, Singapore, Hungary, and North Carolina. And it is a leading manufacturer of professional 3D printers, which are the choice for engineers, designers, manufacturers, dental and medical professionals, and decision makers around the globe. They've been working to expand access to digital fabrication so anyone can make anything. You might be aware already of their products, which include the Form 3, the Form 3B, and Form 3L, which are powered by low-force stereolithography, LFS 3D printing, the Form 2 SLA 3D printer, Form Wash and Form Cure post-pressing solutions, Fuse 1 SLS 3D printer, and Factory Solutions manufacturing solution. Formlabs also develops its own suite of high-performance 3D printing materials that continue to push the boundaries for 3D printing, as well as best-in-class 3D software. And just go to the next slide. So to get a little more into the thick of the material, I have some quick statistics for you, which is good since it seems we're not as accustomed to injection molding. So today specifically, we will be discussing how 3D printed molds can help make injection molding more cost effective and fast. And though I'll let Juliette actually get into all of that, I did want to talk a little bit about the statistics on injection molding itself. As you can see in the two graphs here, the US injection molded plastic market is enormous. In 2017, it was worth about $39.1 billion US, and it's only expected to grow in the coming years. With injection molding, you can use a number of materials, though on this chart, you can also see some of the more common plastics, including several that are also used in AM, for example, polypropylene, ABS, polystyrene, and others. You can also see in the pie chart a little bit below that it can be used in many different industries, for example, packaging, consumables, electronics, automotive, building and construction, medical, and many others. For those of you who are well versed in AM, those might sound familiar, as there's quite a lot of overlap between the industries, notably automotive and transportation, medical, construction, and consumer products. That particularly makes it interesting as the two are already in competition, so it will be fascinating to see how 3D printing can be incorporated into injection molding itself. And just on the next slide, we have one very quick graph, which does not give a lot of information, but basically what it means is it's a quick overview of cost of injection molding versus 3D printing. As is clear, 3D printing does tend to have a similar cost no matter what the size of the run, but it varies heavily for injection molding. For short or medium runs, it does not seem to actually make sense to use pure injection molding. As you can see, it's quite high cost actually, which is not much of a value for many users. Though for larger runs, it is often seen as even more cost effective than 3D printing. However, as you'll soon learn, by using 3D printed molds, injection molding in general can become more cost effective for the short runs as well. And with that, I think I will hand you over to the capable hands of Juliette. Again, don't hesitate to ask questions in the Q&A section, which will be the last 15 minutes or so, or as many as we can get to. And so once again, I'll just say welcome everyone, and let's get started.
Thank you very much for this introduction, Madeleine, and welcome everyone. Thanks for joining. So yeah, I'll first give an intro about the process of injection molding. It was great to see a bit who is the audience and see that we have a share of beginners, but also proficient and experts today. So just like a little recap about this process. So it's a common manufacturing method that use high temperature and high pressure to melt and inject plastic pellets into a rigid mold. And then the plastic cools and solidified into a part. So this is a widely used process, and it's for creating a high quality part with tight tolerance, and it's used for mass production. So as Madeleine just mentioned before, so usually series for injection molding goes from 1,000 units to 100,000 units. It has very low cost per unit, between 1 to 5 euro per unit. It's also a fast production process, so 15 to 60 seconds of cycle time, so very efficient and fast production. And as Madeleine mentioned, it's to produce common thermoplastic like polypropylene, polyethylene, ABS, and so on. So in fact, if you look around you, most of the parts are produced with injection molding probably. One of the, let's say, downside and difficulties in injection molding are tooling. So as I mentioned, it requires the use of a mold to shape the part. And mold can be very expensive and generating quite some lead time to produce. So here's an example of a mold. It's traditionally made of metal by CNC machining most of the time. So typically a mold can cost anywhere from 2,000 to 100,000 euro, depending on the geometry. So if it's a complex design, a complex geometries, it will be much more expensive. And it can take 4 to 8 weeks to produce. So this is mold making for injection molding. It's not really flexible, and it can really slower your process and your development, your product development. So we'll be very curious to know, how do you currently manufacture your injection mold? So you'll have another poll question coming into your screen right now. And if you could share your current process. Perfect. So are you doing in-house metal machining or outsourcing metal mold, or are you already using 3D printed mold, either in-house or outsourced? And if you're using any other method, I'll also be curious to know. So I let a little bit of time. I guess Madeleine, just let me know whenever it's answered already. Perfect, and now we can see the result. All right, so actually most of the people here are outsourcing metal mold. So you must be familiar with this pain of having long lead time and quite expensive mold to purchase. Interesting. Okay, I'm just going to close that. Okay, so now I want to explain a bit why we're talking about low volume rapid injection molding. So if you look at this graph, this shows the typical step for product development. So usually product designer will use 3D printing for ideation concept and producing a few prototype, like feel-like and work-like prototype to have a proof of concept. And then they will use injection molding for mass production. So we can see that there is a gap between prototyping and production, where there is a need, when there is a need for actually having prototype in the final material, so the final thermoplastic that's going to be tested, or prototype in large quantity, so identical prototype for, let's say, pilot runs, or to have extensive testing, or sending to stakeholders. So this is commonly used in pre-production, and also limited series. So when we are not looking into mass production. So for all those applications, there's a gap where injection molding is too expensive to produce the mold, and rapid prototyping takes a lot of time. So this is where 3D printed mold for low volume injection molding really makes sense and can bridge this gap between prototyping and production. So thanks to 3D printed mold, you can actually create mold rapidly. So you can just iterate quickly, creating temporary mold that will help you produce small series, low volume series for functional prototype, affordable pilot run prior to mass production, or also just on-demand production to customize parts and have limited series. So that being said, I'd be curious to know, why are you interested in doing low volume production, low volume injection molding? So you'll have another poll question coming to your screen right now. I don't see the poll question. Ah, I can't hear you, Madeleine. Ah, perfect. All right, so I'll be curious to know why are you interested in this application. Actually, I didn't put other in the solution, but maybe if you have other use, feel free to share it in the chat, in the Q&A or in the chat. Aha, yeah, it should be multiple choices. So maybe just pick the first use that you're having. That's a good point. Oh, right, interesting. Limited series of end parts. That's interesting. I thought it would be more for prototypes, but I guess this is for maybe both options. But it's interesting to see the division between those three. Great, thanks for answering this. All right, so just want to talk a little bit about 3D printed injection molds. So when talking to users, customers mostly goes through resin-based technology for 3D printing. So if you're familiar with 3D printing, you know that there are a few different types of technologies with both advantage and disadvantage. And resin-based printing, and in particular SLA printing, is really a great choice for molding because it is characterized by a smooth surface finish and high precision. And this will be transferred into the final part. So obviously, if you have requirement for surface finish in your part, then it needs to be already in your mold. So 3D prints also produced by SLA are chemically bonded, such that they are fully dense and isotropic, and this really gives fundamental functional mold and good quality to be able to mold and to handle this process compared to other technologies. So SLA is really a good choice for molding because high quality, smooth surface and detail, very high level of detail in your print. And at Formlabs, we have a complete ecosystem for SLA, and we also release some material that have high thermal resistance and are really adequate for molding. And this is affordable and accessible CEST ecosystem that is easy to implement, operate, and maintain. So this is a good choice if you are new to this process and want to set up in your prototyping lab and just start right away without too much pain, let's say. All right, now I want to show a video which is made with one of our partners in China that has been trying this, this application to validate if we can do 3D printed mold for low volume injection molding. So they've been printing with our rigid 10K resin, and they've been printing some housing box. So I'll just show the video and.
Using 3D printers to fabricate molds for low-volume injection molding can reduce costs, shorten lead times, and help bring better products to market. Founded in 2005, Multiplus provides manufacturing services to over 250 clients per year, many of which require small batch production. We've partnered with Multiplus to walk you through the steps of the injection molding process using 3D printed molds. Begin by designing the mold using common design for manufacturing principles. 3D printed molds can incorporate the same components as metal molds. Upload your design into Preform, Formlabs print preparation software. Prepare your print and send it to the Formlabs 3D printer. Choose a material and begin the print. Rigid 10K resin combines high strength, stiffness, and thermal resistance, making it an ideal material for injection molds. All SLA 3D prints require washing and post-curing to bring parts to their optimal mechanical and thermal properties. In just a few hours, your 3D printed mold is ready for assembly. 3D printed molds are often designed to fit within the standard metal frames, which extend lifetime of the mold. Prior to assembly, you may choose to sand or machine the mold to meet critical dimensions. Assemble the 3D printed mold inside the metal frame. Ejector pins can be added to automate demolding. The mold is now ready to be used. Install the assembled mold in your injection molding machine. Insert the plastic pellets, input the required settings, and begin production. Formlabs 3D printed molds are capable of withstanding hundreds to thousands of shots, depending on the part design and molding conditions. Using compressed air can accelerate cooling time, which is typically longer with plastic molds. Whether you're looking to design functional prototypes with end-use materials, fabricate pilot production parts, or manufacture end-use parts, using Formlabs 3D printers to fabricate injection molds is a cost-effective and quick way to produce parts in limited quantities.
Perfect. So I hope you enjoyed the video. This is, oh, that's not supposed to happen. Right, perfect. Yeah, so that was a video to show the workflow step by step and explain a bit how Multiplus did it. Also give a bit of an understanding of different recommendations that will help optimizing the process. So I will dive a bit deeper into the workflow now and also into the case study afterwards, and we'll come back to Multiplus parts. So we have also on our website an application page, so an injection molding page that is dedicated to this workflow, and you can find all type of different assets on that. So I recommend, if you want to have a look and also stay in touch if we have new things coming up on injection molding, that's the best resource that we have. And going through the workflow, I will also mention different assets that we've created, always in collaboration with customers. So we've been working with a lot of different customers that have different equipment, different molding condition, and they share their results with us. And we gather that in different type of assets. So typically we have injection molding white paper that has 3 different user stories, that has design guidelines, also equipment recommendations. So I recommend you to check it out if you're interested. And we also have a quick start guide that will be a very quick 3 to 4 pages document with just a few different steps. So if you're really new to this process, I think that's also the best way to start. We'll also post a different link in that. So now jumping into the different phases for this workflow, started with designing. So first, designing the mold is the first step. So if you're familiar with designing an injection mold, there's not much more to know. It's actually quite straightforward to adapt from a metal mold to a plastic mold. But the one thing to really keep in mind is that 3D printed plastic mold are much more fragile, obviously. So handling the pressure and the temperature of this process will be more complicated. So there are a few modification that you can do on the design to try to reduce the pressure inside the cavity. As I mentioned, we are giving those guidelines in the white paper. So typically, adding large draft angle help, adding large gate, large air vents. So this will all reduce the pressure inside the cavity and increase the longevity of your mold. Also, if a small feature and thin cross-section are present, it also can be more, it can break more easily. So this is also something that we mentioned in the guidelines. And one thing that you saw in the video is that most of our customer plan some stock allowance when they design so that they can post-process the mold with machining the critical dimension afterwards. So this really helps fitting the mold together, both half of the mold together, and assembling the mold to the machine. So that's for design. For complete beginner, we have a webinar that we've done with a teacher from Technical College in the US. That is, he's a teacher in injection molding, mold design, and he's using 3D printing mold in his class to teach his student on how to design an injection mold. And we've done a master class with him. So this should be helpful if you're really starting from scratch on this process, but also if you're already familiar with injection molding, he's giving some recommendation on how to adapt from metal molding to 3D printed molding. Second step is how to print. So once you have the design, you need to print the mold. We have one material at Formlabs that we recommend. It's the rigid 10K resin. It's a fairly new material. I mean, we released it last year. So maybe if you're familiar with Formlabs, it's possible that you haven't tried it yet. It's a highly glass-filled material, so it has very good stiffness. It's strong, and also it has very high thermal resistance, so HDT of 218 degrees. So this is a very good balance between handling the temperature of the process, but also being stiff enough to handle the pressure. So we give a few recommendations on, for example, how to orientate the part before, how to print the mold. So printing the mold flat help to have better results, also without any support, to not have any mark on the molding surfaces. The mold can be sanded afterward, that's what I mentioned, or machined as well. And before processing, before molding, it should be placed into a metal frame. So this will absorb the pressure of the process. It really helps to increase the longevity of the mold. Yeah, so that's some recommendation about printing. As I mentioned before, we've been working with a lot of different customers. There is no one way to do it because it will depend on the geometry of your part. It will depend on the material injected, the temperature, the pressure. So we wanted to gather in this data table all different process conditions that our customer have tried. So here you can, like, obviously you cannot read it right now, but it's just to show the format of this document. You can find feedback from a lot of different users with what injection molding machine they used, what material they injected, what temperature, what pressure, how many parts did they get with one mold, and at what cycle time. So this should be a very good reference if you are thinking about doing this process and are wondering if it's going to work with your condition. So typically, I just wanted to put a few information here from this table. So what we observed, so we injected a lot of different material. When I say we, is our partners and customers. So here are the ones that we can say works, TPE, PP, PE, ABS, so you see it listed here. And in general, injected temperature up to 250 degrees have led to about 100 of iteration per mold. And then when we went higher, 260 and 270, we had about 10 iteration. So it's like much more difficult when it gets higher temperature. Also, we saw, depending on the type of plastic, the type of material injected, that some were easy to inject, like polypropylene is easy to inject, PE as well. Some are more complicated, like nylon or polycarbonate. So we usually have about 100 of parts also for materials that are easy to inject, and just about 10 parts for those ones that are a bit more complicated. All right, so now I want to dive into some user stories. So those are concrete examples of customer or partners that have done some tested with a lot of different machines. So you can also find those stories in our website. We have blog posts and we have white paper about it. And again, those information and in particular the technical data are available in this table that I just showed before. So first I want to come back on this video that I just showed. So as I mentioned, this is a partner from China called Multiplus, and they've injected a control box housing for home appliance. They've also tested a lot of different geometries like bottle cap, yeah, some that were commonly produced for in low volume. And they tested different material like PP, ABS, polycarbonate as well, and PC ABS as well. So for all of them, they gather different, they gather all the different results, and most of the time they got about 100 of parts, or they got lower, but the mold didn't break, they just didn't test further. So yeah, that's also, you can find all those different tests in the user story. They were using small scale hydraulic press, so industrial press, from the brand Babyplast. So this is a complete industrial setup. They had the injection molding room, but they also had the assembly room, as you could see on the video before. And as I mentioned, they were machining the mold before assembly into a medallion frame. So you can see here an example. So this is the geometry that you can see in the video. This is to show you a bit an example of geometry that works well. A second use case that we mentioned and that we've been a customer that we've been working with is the company called Formlabs Applications. They are a product development company, and they also need to produce low volume production for series of prototype for the customer. So this is really something that comes back very often for them. They are expert in molding. They've been molding and in injection molding. They've been injection molding for years and years. And they actually were beta tester for this material, for the rigid 10K material. So they're using as well an industrial press, all electric semi-motor 60 tons press. And they injected about hundreds of parts with quite a complicated mold. So it's a 3-part mold that has also a side action part. So you can see on this slide. And this is to inject a bottle cap. So pretty common piece for injection molding. You can also see here in the preform software. So this is really a good example of delicate part. I come back to this delicate part with a side action core and a 3-part mold that was successful for about 100 of iteration. Another case that I want to mention, it's a company called Brasscam. So we've also done actually a webinar with those 2 customers, Brasscam and a novice application that I just mentioned. And this webinar is very interesting because they share all the design process and all their recommendation for injection molding with 3D printed molds. So I really recommend to check it out. There's also a very interesting Q&A session at the end. So I think this is very good learnings. So Brasscam is one of the leading material supplier for injection molding. So it's a big material company, material supplier, and they are doing some innovative project to find solution for temporary mold to help their customer to have access to temporary mold and gain flexibility in production with in-demand mold fabrication. So they tested this application with an internal project during the COVID phase, where they had to produce about 6,000 of mask straps for the employees. So they were under a lot of time pressure, actually. And for them, 3D printing will not have been an option. Direct 3D printed and injection molding was obviously way too long to produce the molds. So this is when they actually start doing 3D printed injection mold. And they managed to print thousands of mask strap with only one mold. So they actually got 1,500 iterations per mold. So that's pretty interesting. They were injecting on an industrial press, all-electric Sumimoto 60-ton press, and they only needed 2 days of lead time from ID to production. So that's really an example of how quick they can be reactive, how quick they can go from ID to production with this method. So producing thousands of parts from the moment they decided to do it, they need only 2 days. So an example, a picture of the mold and the design. So this is a design that is pretty simple with a very flat geometries, not too much internal features. So this also explains why they got such good results with thousands of iterations per mold. They also had very large gates, as I mentioned before in the design guidelines, large vent, no thin cross section. So as I mentioned, the geometries will have a huge impact on the longevity of the mold. All right, so that's for Brasscam. Another example I want to show, and that's interesting as well because it's a company called Holymaker that is producing desktop injection molding machine. So I know a lot of people are interested in doing this process but don't have the equipment in-house yet. So we've been working with a few different desktop manufacturers for injection molding machine, and those are very easy to use and easy to set up. Obviously it's small scale, but this is definitely a great solution if you're new to this process and want to start prototyping part with the final material and do like some small series. So they Holymaker, so as I mentioned, they are the manufacturer of this machine, and they offer feasibility study for their customers. So they produce like series of hundreds of parts for each customer, and help supporting on design and feasibility, technical feasibility for each. So I just want to show a few design that you can see. So this was some soccer cleats that they've done. This was some face shield clips and some eyewear as well. So just some idea of designs. And one last use case I want to mention is Technical Research Center in Plastic and Composites from France, actually, that we've been working with. And they have run an extensive study about 3D printed injection mold. We have a white paper, like a technical study that we published with them. So we will also post that in the link. So it's quite interesting because they also compare different 3D printing technologies. You can find the extensive report on their website or directly reaching out to them. And they've been testing charter parts, so with different critical dimension that they wanted to try. They also insert some patterns. So you can see on this picture, there are some very fine patterns on this mold. And what is special with this mold is that it is multi-material mold. I see which material is this. So it's a multi-material mold. So the core of the mold is printed with rigid 10K. As you can see in the left part, this is all this white resin that I showed in the example before. But they also printed the frame of the mold in SLS with selective laser sintering technology. So the frame of the mold is actually in nylon. And why did they use that? It's because there is a common difficulty, let's say, with 3D printed mold is just fitting both half of the mold together to reduce flashing. And with using a frame in nylon, they could have enough flexibility to clamp the mold perfectly and reduce flashing. So this is a very interesting case. They got thousands of iterations with only one mold. So it has very good longevity. They were also injecting on the industrial press, I think Engel, 150 tons. Polypropylene, and temperature of injecting was about 200 degrees Celsius. But as I mentioned, we'll just post the link so that you can see exactly all the conditions that they were using and the different equipment as well. They added some insert, as you can see on the left side, those different parts here. And as I mentioned, some very fine patterns to include in the final part. So this is a great example of multi-material mold and how to use the different properties of the printing material to really optimize this process. So yeah, we'll just share this white paper, this technical study. And again, this is all those information and technical data are in the table that we will share afterwards. So that's it for the use case and for this presentation. So I just want to thank you all and mention the next step. As we mentioned, so we can, if you're interested in this, we can request a free sample part to check the material. So you can check how Rigid 10K feels and perform. And you can also go online and check our material tool to see what material will fit best. So one last poll question. Yeah, we are interested in what volume of production you're doing or planning on doing with 3D printed injection molds. So yeah, I'd be curious to see if you're looking into producing a lot of parts, or it's just like a few parts that need to be in the final thermoplastic. So you can answer directly, and then we can see the result afterwards. So that's the last question before going to the Q&A, and then we can have a proper discussion. All right, 10 to 100 parts is the maximum, is like the majority of your use. There's also quite a lot of people that are interested in producing more than 1,000 of parts. That's quite interesting. Well, as I mentioned, we did have some case of a customer producing 1,000 of parts, so that's definitely doable. And also, what is one of the advantage, obviously, of 3D printed mold is that you can print multiple mold easily. And quickly as well. So let's say if you get like 500 iteration with one mold, then you can print multiple one and scale it. You will not scale it to 100 or 1,000, but it's definitely doable to go to 1,000. All right, well, thank you very much, everyone. And now we can go to the Q&A session.
Indeed. Well, thank you everyone for starting off with the questions. As you, well, I think at least one person has figured out, you can actually vote on questions if you'd like. So if there's something in particular you'd like answered, don't hesitate to vote for it, and that way I will be sure to see it. But well, we can start with this one just because I know it was the first question as well. What materials can be injected using rigid resin normally? And with HT resin, question mark, is there something like a list of the most suitable materials, or is it something that needs further investigation depending on geometry, cavities, thickness? I think you kind of addressed this later on, but.
Yeah, so this is like a question that comes back very often. So as I mentioned, we don't know like all the material. We haven't tested all material, but we have quite a lot of feedback from different customers. So you can find on this table the process condition. You can find all the different material that we've injected or that our customer and users have injected. We recommend to use rigid 10K no matter what. So always go with rigid 10K. We do have customers that were using high temp resin or also gray pro resin, but it's because rigid 10K is new. So high temp was the preferred material before because it has good thermal resistance. But for now, I will always recommend to go with rigid 10K. And yeah, we have a lot of different material like polypropylene, PA and so on that works well with those.
Okay, well, we had quite a few questions come in at once, so we'll try and get to as many as we can, but we may not get to all of them. The next most popular question is, how do SLS and FDM technologies compare to SLA for 3D printed injection molds?
Yeah, so as I mentioned, SLS and FDM are technology that are less accurate, that have less fine details. You cannot do detail that are as fine as SLA, and the surface finish with SLA is also much better. So this is why most users go for resin-based technology like SLA because of the small surface finish and the high level of detail. So yeah, I will really recommend to go for that.
Makes sense. Another question that is popular is, do you see 3D printed molds to be suitable for high performance thermoplastics, ULTEM, PPSU, and such in the future?
So it really depends on the temperature injected, obviously. So I mean, I would be actually very curious to have feedback on those one. So if the temperature is really high, I guess that will be quite difficult. But I think this is the process that demands to try. So it's really an experimental process, and I'll be very curious to have your feedback on that if you're trying to inject those material. But yeah, it needs to be tried.
Or maybe it will be soon.
Yeah.
Well, next question is, do you have any experience with PLA? And if so, do you know of any maximum dimensions with the material?
No, so I haven't had any feedback on that.
Another question is, how repeatable in terms of tolerances are the parts made from plastic molds?
So rigid 10K has very good dimensional stability. So in terms of dimensional variation, you will have greater variation than in a metal mold, obviously. So that's why I recommend to plan some stock allowance first in the design and then machine the mold so that you can really plan on dimension variation. But then the dimension stability is actually very good. So we've had some customer trying like the repeatability and measuring the variation over time, and it was pretty low.
Okay, thank you. Another popular question is, what's the difference between classic insert over molding and insert over molding using 3D printed molds, if any?
We do have customer doing over molding with 3D printed mold, so this is definitely possible. Let's say the same challenge goes for that. So it really depends on the temperature, just the geometry of the mold can break more easily, but otherwise it's definitely doable to do over molding with 3D printed mold.
Great, thank you so much. a few questions from a few repeated questions, but the next one I see is, what is the longevity of a 3D printed mold and how does the mold fail? Also, if you could clarify what short run means.
Yeah, so I would say I'm fairly confident to say about 100 of parts for material, like as I mentioned before, that are easy to inject, like polypropylene and so on. So we've had enough feedback that goes from 50 to 100 of parts for this kind of material. So yeah, I will qualify short run from 50 to 100 of parts per mold. And that's, as I mentioned, is for easy material to inject with temperatures that are under 250 degrees. How does the mold fail? It usually cracks.
Short and sweet. Okay, well, another question is, what material do you recommend for a medical device?
I don't know. I'm not at all into this area. Sorry, I cannot help.
Okay, another question that is actually about molds. Are there residues from 10K resin mold in the parts, and is biocompatibility given?
So it's a great question because rigid 10K is a resin that is highly filled in glass particles. So when printed, I don't know if anyone is familiar with this resin, but when it prints, it has a little bit of a powdery aspect at the surface. And this is really due to the chemical composition of this resin, and it doesn't impact at all the mechanical property of the intrinsic property of the part. So we recommend to wipe this part with mineral oil to diminish this powdery effect, but it can affect the first injection, so you can have a little bit of powder on the first part if you see it. Usually we didn't have too much feedback on this being a problem, so most of our customers haven't observed it, but it could happen. Otherwise, the chemical reaction between the resin and injecting material, usually it doesn't react. And also, I know that it's also a common question with using mold release agent. It also doesn't react with the with the printing resin.
Great. Well, I'm going a little, just warning everyone, I'm going out of order. It's me. I just saw a question I thought might be interesting, which is, what are the design considerations for 3D printed molds versus metal molds? Can you add ejector pins? Should you add cooling channels?
Yeah, so yeah, this is like a question that comes back often. So in general, going from, if you're expert in designing injection molding in metal, there is not much more that you will have to learn. As I said, we have this teacher from Technical University in the US that is teaching his students with 3D printing molds. So he's teaching his class on injection molding metal, and he's teaching with 3D printing molds. So there's not much to consider, but you can add some larger draft angle, larger gate, larger vent, just to help diminishing the pressure inside the cavity and extend the lifetime of the mold. So that's really some tips to make the lifetime of the mold longer. Adding cooling channels. So this is also a recurring questions on how to cool the mold. So because 3D printed mold like plastic has not the same heat transfer than metal, usually it doesn't really impact much to add cooling channel in the mold, and it's more complicated to print. So none of our customers are adding cooling channel. This is not really something we recommend. Maybe for very large mold, it could have an impact, but so far I don't see it being worth it in terms of balancing design complexity and time of cooling. So for cooling, I will suggest to use compressed air. So we have most of our users are using just compressed air, or also sometimes they just change the mold. They have like replaceable mold, and so they wait that one part is cooling in one mold and inject with another one. So there are some tricks like that you can use. I think there was another question. Yeah, ejector pins. Yeah, you can totally accommodate ejector pins to 3D printing molds. So we have customers that automate the demolding process.
Good to know. And the next most popular question, if you know the answer to this, is what is the largest injection mold size for 10K?
So far, I have been working only with customers that work with the Form 3. So up to the almost the full build volume of the Form 3, which is, I don't remember what it is, but it's yeah, it's like up to the full build volume works perfectly fine. I haven't had feedback from customer working with the Form 3L, which is 5 times the build volume. It should be more complicated, first because dimensional variation will be greater with greater parts, like with bigger parts. So that will be the first issue. And obviously the pressure will probably impact bigger part of the mold. So I would say full build volume of the Form 3 works great, but obviously the smaller the better. So I'll be surprised. I'll be curious to have your feedback on mold size if you can share that.
Well, I guess we'll see what everyone else comes up with. Another question that was popular is asking whether DLP 3D printers do the same process or similar for making molds.
So DLP is a resin-based printer, so it's a similar process. It uses resin as well.
Perfect. Okay. Well, another question that I see is how do the capabilities to handle small undercuts, CA 0.5 millimeters width, differ between 3D printed molds and metal molds?
Yeah, 0.5, yes, so small undercuts are tricky. And usually, yeah, I would say it might be, yeah, it might be a bit small, but it really depends on, I guess, on the material injected as well, the pressure. But yeah, the smaller you get with fine feature and small undercuts, and the harder it will be. We have also in our white paper some data on that, on small features recommendation from customer. So I recommend to check it out.
Good. Well, thank you. I think we're nearly out of time, so I think maybe just the last 1 or 2 questions. If you still have questions that aren't answered, sorry guys, we've tried to answer as many as we can. You have a lot. Do feel free to reach out to Formlabs and they can answer your questions for you as well. Well, I guess this is the most popular question. So if you're looking for injection molding partner with rapid tooling, do you have a recommendation for someone to work with, maybe among the listed companies?
This is a question that comes back very often. Actually, we haven't we haven't built a database of collaborator to recommend, but this is maybe something we should think of because a lot of customers are asking. We will also have to make that, I guess, region based. So yeah, so we don't have that right now, but I'll think about that, making maybe something on our website where we can recommend molders in your area. It's good feedback, good question.
And then, well, I'll just, now they're all voted for the same, so I'll just choose a question, which is, can 3D printed molds be post-processed so that some surfaces have, for example, rough matte surfaces, while others have a smooth, glossy surface?
So it can. So far, customer didn't give like such good feedback on glossy, for example, and matte. I know that Novice Application, this company I showed in the presentation, they didn't really manage to get a very glossy finish. but yeah, in theory it can be. So it's just the question if does it work very well with the injection molding process. So I cannot say too much about those results. I didn't have too much feedback on that.
And maybe, well, we still have 1 minute, so I guess we can just do one last question. Out of all of those, well, this is quite a long question, so why not? If you want to produce different part geometries, you need ejector pins at different locations for each part. How can one avoid having to mill a new mold frame with individual holes for the ejectors for each new part? It seems it sounds counterintuitive to the goal of short lead time.
Yeah, so let me think about that. Yeah, so I mean you'll have to mill anyway. So I know that most of our customers are anyway post-processing the mold every time. In general, they have like desktop equipment in-house, like desktop milling machine, or you don't need something too complicated. But yeah, this is something that usually it's a quite important step in the process. But we do have customers that choose not to integrate ejector pin for sure. A lot of our customers are not doing automated. So I guess it's a bit up to your case. If you need to produce a lot, then you will want to automate. If you have just a few parts and you are under tight pressure, maybe you don't want to add injector pin. So this is really like case by case, I guess.
Well, I think we can probably end on that question then. Again, guys, do feel free to get in touch with Formlabs if you have any questions that were not addressed during this time. There were a lot of questions. And with that, I just want to say thank you very much, Juliette. It was a fantastic presentation. I appreciate you being here, and thank you everyone as well for coming. I hope you enjoyed it. Again, for anyone who is interested, the replay of this webinar will be up on YouTube in the next few days. If you'd like to be notified when it's up, just subscribe for notifications from 3D Natives. Otherwise, it will be there.
Thanks a lot, everyone. Thanks for your attention and your questions.
And with that, I will say have a good evening, morning, day, afternoon, wherever you may be, and hope to see you at the next webinar. Bye.
Bye.